This is exercise 2, and we're transitioning to Linux, which means that the first lab was in Windows. Now we're doing a lab in Linux. We're going to get some familiarity with some system commands. We're going to run and compile in Linux. We're going to talk about the processes versus threads a little bit, working with process on Linux and compilation in Linux environment. Okay. Welcome again. Why are we saying welcome again? Because it's like it's a new course, because we're doing Linux now. Unix was the first operating system that could run on multiple platforms, I guess multiple hardware. It is known for the stability and reliability and its ability to handle a variety of tasks. It's stable. People who have Linux or Unix machines will pretty much use the terms interchangeably, by the way, Unix and Linux. But there is a difference, which I may discuss. But anyway, people who have Linux or Unix machines like to brag about how long their uptime is, that haven't had to reboot their computer in ages. Windows likes to reboot your machine. Why is that a problem with a server?
Downtime.
Yeah, downtime. All of a sudden, somebody's watching, using your server. They're playing a video game on your server, and then all of a sudden it disappears. So you don't want to ever have to theoretically ever turn off and restart your server. So Linux is more stable. The Linux operating system was developed based on the Unix operating system. It's free and open source. The main difference being that the Linux was designed for a PC, which is all the computers that you have, unless you have a Windows machine, unless you have a Apple machine. Apple machine, I believe, was based on FreeBSD, but another kind of Unix. Apple actually has Unix native, which means that if you ask for a black screen for the command line shell, you'll actually be running commands in Linux. At least that's what it was for a while. I don't know if it still is, but it's not still. Is Apple still like that?
I don't know. I don't have a Mac.
You don't have a Mac?
Ubuntu. Mac is Unix.
Yeah. Okay. So today Linux.
It's Unix based. I think they changed it or something. It's
Unix based. Yeah, I think you're right. So, but basically, all the commands that we do now should probably work on your Apple machine without installing anything. But if you have a Windows machine, then you're going to need to install WSL. Which I made a tutorial for once a couple years ago.
I have a question.
In fact, it's only 10 minutes. I recommend you watch it all before you even start. Just watch 10 minutes while you're on the bus. Watch my tutorial. I show you everything you can do with WSL.
Where is it?
It's on YouTube.
I don't need it. I don't know.
Just type WSL.
Nachum Danzig WSL tutorial, and you find it.
I already have WSL.
Don't do it now. Don't do it now. This is for later. You can open up the tab, but then get back to what we're doing.
I have a question.
It has a variety of distribution versions. Now there's different versions of Linux, and it can be run in a variety of computers. When we say distributions, we don't mean that a different version. We mean distribution, like different companies are distributing it with different things combined with it. Yes.
So you say Debian or
Debian and
then
Ubuntu are
that's-
two different distributions of Linux.
Yes, but at the end of the day, if you say like I don't know Linux, then it's not really like another distribution. It's built on top of another one. So,
I'm not saying everything is a different distribution.
okay. Is there? It is kind of related to the course. Is there a way to like lock the bootloader on like by software in a Windows computer so that you cannot put Linux on the same ROM?
No, I don't think so. I don't think so. You have to look for a tutorial on how to do a boot, and I think you'll always be able to do it. Okay, a little about Linux server. Naturally, when you turn on the lab computers, if you're in the lab, then the Windows operating system starts up. In order not to work with Windows, but with a Linux operating system, and if you don't want to install WSL, so then you can teleport or telnet or SSH. Actually, you can use an SSH program to connect to the Linux servers. In Mahale, they're called LINAP, LINAPP, like Linux application server. And then you could also run commands remotely on the server. But I recommend you all install WSL, but not now. While working with the Linux operating system, your computer becomes a terminal that works with the central computer. Now, if you connect to LINAP, then you're just a terminal, which means you don't really do any computing on your computer you just send messages to the other computer and it does the computing. Usually, without being aware that they work simultaneously, usually without being aware that they work simultaneously on one computer. In other words, everybody on that one computer is working simultaneously on the same computer, and they don't even feel that they have other people there. Working with a central computer is transparent. Now, you don't notice that there's other people there. Now, there's something called a shell program. So when working with Linux, you work in front of a window that allows you to enter commands. It's like the black screen of Windows. Of Windows, there's also a black screen of Linux. This window is similar to the CMD thing that you saw in Windows. It's called a shell or a terminal. Why is it called a shell? Because it's an interface or a wrapper around the operating system, much as a clamshell wraps around the clam's flesh, right? The kernel is or a shell maybe of a nut, of like a walnut. The kernel is the kernel, the seed in the middle, and around it is a shell. So the interface for you to the operating system is called a shell. That's why it's called that. The reason why I talk about clam is because there was a picture of clam. The interface or wrapper for the kernel of the operating system lets you activate the kernel of the operating system with various text instructions. In other words, I can ask the operating system to do things through text. It is possible, so it's convenient to open several shell windows at the same time. So in other words, you can have multiple shells open and it's all you using them. You can type, you have to move from one window to the other. Note that Linux / tilts to the right as opposed to Windows, which leads to the left. And of course, to the right and right. So here are some commands. Anyone know these commands? Anyone know what ls is?
Yeah, list all the subdirectories, something like that, all the
Well,
files.
list
The current directory.
what about the current directory? What do you mean list
All the files, everything that.
all the files and directories in the current directory?
Non-hidden,
What?
non-hidden files.
Yeah, they're hidden files that I won't show you. ls minus l. By the way, there's a lot of the commands have what's called a flag. A flag is always preceded, or almost always preceded by a minus sign. There's a few cases where it's not preceded by a minus sign. So the flag is like how to run the command. There's a third field, which in red here is written directory or file. And that's called the operand, which is on what to operate the operation on. In other words, you operate the operation on something, and you have a flag how you operate it on it. So what this means is ls list the files on what directory? I can specify a directory. Here I didn't specify, so it's the current directory, wherever I'm sitting, whatever folder I'm in. But here I can specify a directory, what's called what you call a folder, we call a directory in Linux. So I can specify a particular directory or a list of files. I can write file name, and then it'll print out the details of them. Now the minus L over here means that it's not just a list of the names of the files, but it gives me further details. It's what's called long form. So long form is the L for long form. PWD is another command. PWD, present working directory. It tells you what directory you are currently sitting, what folder you're in. It tells you the name of the folder you're in, including all the slashes and the directories above it. So you can know where you are on the tree of files.
I think those were also in Windows, exactly the same.
Could be that all these commands are probably copied into Windows. CD, there's a lot of CD commands, but CD tilde means go to my home directory. Every user, when they log into a remote system, they have a place where they get to when you first log in. That's the place, that's your home directory. CD slash would mean go to the top of the eights. Slash like that, forward slash means go to the top of the eights of all the files. And then I can go from there down. I could also write slash and then write a name of a directory. And then it would go into that directory, assuming that directory is at the root, is at the top. I could also do CD directory. That means if I'm in a current directory, but in my current directory, there are many directories. And I want to go into one of those subdirectories, I just do CD directory. CD stands for change directory. And then mkdir is make directory. It makes an empty folder. And I have to, again, what's in red is the actual name that I want to give it. which should be either a directory or a file here. There's a command called pico, which is an editor. Pico.
I don't know that one.
Pico is an editor, it's like nano,
Oh, no.
it's the same as nano. And then I write the name of a file, and if the file exists, it'll open the file. If the file doesn't exist, it'll create the file and it'll be empty. And there's touch, but it'll open the file. If the file doesn't exist, it'll open it. Touch doesn't open the file. Touch just creates the file. Does more than that though. If the file already exists and I say touch on it, then it updates the last modified date. It tells me that it was last modified today. Or at this moment. Okay, that's just 3 commands. Now, we'll show another command. This is all one command called top. Top, if I had to say it's something like what it's like that you've seen already, it's like Task Manager. It's not as powerful as Task Manager, but it's similar. So let's see what it does. You type the word top and you get all of this. See, when they wrote that $sign and then the word top, that means that it's called command prompt, the $sign. It means this is the computer saying, hi, I'm here and I'm ready for your command. And then you type in TOP and you get this whole output. And let's see what it says. Linux runs multiple processes in parallel. To see the processes running now, type top in the terminal. So here we see processes. They're owned by Joe, and these are the name. These are the actual processes on the right. That's the name of the command that I ran to get this process up and running. But let's go into a little more detail. Here it says the system and how many hours it worked. In other words, a kind of uptime. I think an hour and 57 minutes is its uptime. And this is the time of day over here, I believe. And then processes currently running in the, I'm not sure where that is. Anyone good at what's that game called? Where you have to not match game. Price is Right, not Price is Right. Wheel of Fortune. Anyone good at Wheel of Fortune? Processes currently running in the
System.
there you go. System. Thank you. Very good. That was a specially designed trick for all of you. Took me a long time to get that to work out. Okay. So process currently running in the system. So you see this 280 processes, 2 are running, 220 are sleeping. That's kind of normal actually. Because most processes at any moment are probably not doing much. Stop 0, zombie 0. We talked about zombies. Did we talk about zombies or not? If we didn't, we will. CPU statistics, percent of usage and more. So in other words, here it says, you see on the left, it says CPU, and it says, I guess 0.7% used. CPUs mostly not doing anything. RAM statistics. So this is like how much free space I have in my memory. See, it says memory over here on the left. I think it's KIB. That's kilobytes. By the way, we a lot of times abbreviate kilobytes. This is my new thing to tell everybody all the time now. We a lot of times abbreviate kilobytes as KB. But it correctly should be written KIB, like it's written over there. Because KIB means 2 to the power of 10. But if you write KB, technically, even though it's not really used that way, at least in Nachum it's not. But KB, let's say, in a very technical sense, means 1,000. The actual number 1,000. Whereas 2 to the 10th is not 1,000. 2 to the 10th is 1,024. So if you write KIB, then you're technically being correct. KIB means 2 to the 10th. 2 to the 10th, I guess the units here is 2 to the 10th, so that, I don't know. That seems like a lot if it's 2 to the 10th.
Yeah, my console just has it in megabytes, so it's easier to read.
No, but I'm saying even this number seems too big
That's how many?
to be, this is 16 million, yeah, so giga, okay,
That's
this is 16
gigabytes.
million kilobytes.
Yeah.
So that would be 16
Gigabytes.
gigabytes, so that's fine.
Giga.
So now it says of that, 11 gigabytes are free and 2 gigabytes are used and 2 more gigabytes are, I don't know what. Virtual memory. So when it says swap over here on the left, that means virtual memory, which means that actually some of the disk unbeknownst to you, some of the disk is being used as memory. We're gonna talk about that.
We saw that while doing the homework, I think.
Yeah,
I started seeing how much my computer had for virtual memory. I don't know if that was what it was using or that's how much it was willing to use. But we had that in one of the processes.
it's usually what a defined amount. I don't know.
Yeah.
I don't know
think
what,
so.
well, here it has different things here. It may be, there's different columns. There's an amount, there's different, there's a total and there's free. And there's available and there's used zero. It's not using any. I guess that makes sense because there's a lot of free memory anyway. Why would you use swap when you have 11 gigabytes of free memory? So that makes sense that it's all free. Reminds me, I went to a restaurant that was macrobiotic and it had a sign there that said, all wheat free. And so I said, could I please have some wheat? And they said, but we don't have any wheat. I said, what are you talking about? You're saying all wheat is free.
Wheat for sheep.
All wheat free.
What? Because it's wheat free, it's like gluten free.
Right,
So it says it's all wheat free.
yeah. So I said, I want some wheat, if it's free. I
Give
want
me some wheat.
Give me some wheat. So here, you have free space.
By the way, is there lecture homework in this? I just,
There will be probably, yeah, there will be.
Okay,
There's supposed to
cool.
be like
I just-
three assignments, yeah, I put, that's why I put it all in the same.
okay, cool, thank you. Want to make sure.
There will be, don't worry, I'll try to refer to you as much as possible.
Thank
You
you.
were able to do the homework?
Yeah,
Yeah.
it was just a bit like,
Yeah.
sometimes I didn't know exactly what it wanted or how to find it. Sometimes like, I hope I was screenshotting the right thing, and other times I think the question was just like formatted wrong.
Yeah.
Like one of the questions just asked, what?
Yeah.
One of the questions just asked, what? Question mark, you know, it was like, find the process explorer running for all the systems with Chrome. What? What are we doing here?
You have to have mercy on me, I have like
It's a,
a
it's,
ton of stuff to.
I'm sure you're
translate.
translating for like the entire college, it happens.
I really am translating today. I'm translating two very heavy.
You use
books.
ChatGPT?
I don't, maybe I should, so I never tried that.
It's very good.
I'm using Word itself as a translator.
Oh.
Translate also, you can paste documents into
But then I have to go over it, but I want you to know, I go over it. And I fix it, but I just miss
Alright.
things sometimes.
No, it's great. I just hope you don't penalize us for the what question, because we were guessing there.
Yeah, okay.
If, just please, the what question, just smoke on it.
Well, yeah,
It's not.
a while. Okay, now,
What?
so far we explained the upper.
Oh, what? Oh, I get it now. I get what you're doing. Alright.
No, there was a question.
What? He said what?
There was an image that wasn't on top of the questions.
Oh, yeah, we missed you have to go back to the Hebrew one to find the question. Say, what?
The person was in Hebrew.
Yeah.
Yeah.
It's okay.
Well, I changed it a little bit. I don't know if you got the most recent version, but I changed it. As people pointed out to me, that there were some mistakes I fixed.
I think we did enough, alright. It's cool.
Okay.
Yeah, it should-
It'll be okay in the end. If we all fail, we all pass, right, you know?
Not necessarily. Okay, so what we've explained so far is the headings at the top. Notice there's a white line here, and underneath it is actually a list of all the processes. So far, we've talked about like general things about the machine. Now we have a process list. So from here on, the list of processes we're currently working with relevant data. So process number is a PID. Not Philip I. Danzig, but process ID.
It's not printing, it's working on real time. That's what I just realized.
Owner. Who owns the process?
It is on real.
CPU usage, percent of CPU that's being used by that process. RAM usage. That was very small, okay. Comma, so some more commands for the terminal, and I didn't translate this because it's too hard. I didn't wanna waste my time, because I can just tell you. Top
That's fair.
is, we've seen what top is. Now, the problem with top is that it might have a lot of data and it goes off this terminal, so we might want to put it in a file. So look what you can do in Linux, it's a beautiful thing that you can do. You can say top, and then the output of it, I'll explain this in a minute, but the output of it, arrow into top.log. So that means I'm actually creating a new file now called top.log. By the way, if there already was a file like that, I'm overwriting it. I'm deleting it and recreating it. And all the data up top will go into this top.log. Now the minus B means batch, and then minus N is number one, which means just because what actually I didn't explain is the top is actually constantly updating. every second or it's something, it's rechecking, just like Task Manager, it's constantly updating. So the top command is, you see, the top command is updating, and I just help, when I write one, n minus n1, I mean, just update once. Just give me the first iteration, don't keep iterating.
A very classic example of using this is when you have like a virtual environment and then you wanna put all the things that you like install into one file so that everybody else can have the installation file, then the command is very similar to that.
Yeah, the arrow is very
Arrow,
nice.
yeah,
Arrow
yeah.
one file. So PS lists, PS is like top. But instead of giving me like a active, by the way, how do you get out of top? If you type the command top,
Control C.
Yeah,
Control C, Control X, depends.
I'm not sure if you just type Q, no?
Yeah.
Let me see.
Q, I believe it's just Q. For quit.
Oh, it's Brazil, that's.
Yeah, both work, Control C and Q.
And Q. Okay, so PS is similar to top, except what it does is it just prints out all the processes that you have. You know, it's kind of like the bottom half of top without the top part. Then you have PD of, and then you give it,
data.
and then you give it a name of a process. So PD of bash will tell me, I'm not gonna explain the minus X, but PD of bash means give me the PID, the process ID number for the process called bash, assuming it exists. Now, PS 2355 means show me details about process number 2355. See, PS, if I type PS minus EF, then I'll get all the list of processes and I'll see the number. Then I could write PS of that number and I could then see that just that one process. I could also type kill of that number, of any process number, and that will kill the process. It will turn it off. It'll also called, you know, assassination. Sleep 600. Sleep is a nice command. Sleep just does nothing for a certain amount of time. And if I write 600, it's 600 seconds.
The CPU stop.
There's also another command called usleep, I think it's called. Okay, what usleep? And it's instead of in seconds, it's in microseconds. Yeah, can somebody check that? Is it? I think it's usleep. I'm not sure.
That's a question for GPT.
Now BG, there's two other commands, BG, FG, and jobs, or three other commands. Jobs lists for me all the processes that are running in the background. What does it mean for a process running in the background? A process running in the background means, well, actually, I think the next slide is going to explain. And yeah, let's do this. And there's BG and FG. BG is background and FG is foreground. Basically, if I have a process running and I do Control Z, I will freeze the process. That's Z. I always think of as like sleeping it. It's like when you have a cartoon and you want to say that a cartoon character is sleeping, you write in the balloon, in the cloud, you write Z. That means he's sleeping. So Control Z puts the process to sleep. If you then, after you put it to sleep, you type FG, it'll come back to life. If you also do Control Z and then type BG, it'll come back to life, but it'll be running in what's called the background. That's what BG stands for, background. FG stands for foreground. So it's running in the background. Why is it running in the background? What does it mean it's running in the background? It means that it's not using the terminal, that I can still type things in the terminal even though this process is running. And jobs tells me lists me all the processes that are in the background. So that's very briefly a few commands that are in Linux. I mean, there's a lot more. Start programming on Linux. We will now, we're not going to actually do it, but we're going to see this demonstration. We will now open a new file and type the following program into it. We will compile in the shell by using the GCC compiler. So here's the program, and as you see, what does it do? It prints 5. Print F, by the way, is how you print. D, %D, did you learn this already?
This is just like string from.
Yeah, you first you say print F and you put something in quotes. Your quotation. And then you do %D means that I want a decimal number here.
Yeah.
And then \n means I want a new line. So what decimal number will I put there? The one that's after this comma.
Things we
Which
just
is I.
plus.
So it's gonna print 5.
No,
Then I'm gonna do I++ and print 6. That's all the program's gonna do. So a basic program. first thing I have to do is compile it. So I write this, GCC stands for GNU, anyone know what GNU means?
Not fast.
What?
GNU is not units.
GN, no, what?
GNU is not units.
GNU is not units, but what else does it stand for? What else does it mean? It means wildebeest. GNU is an animal.
Oh, new.
Something compiler, probably.
It's a GNU, it's
an alien.
What?
It's a word. The word?
it's an animal.
It's this animal.
Isn't the G silent?
It's a wildebeest.
It's a good.
Yeah.
It's a GNU.
Isn't the G silent?
Probably, so it's a
I think
new.
it's a new.
It's
It's
a
a
new,
new.
Yeah.
Oh, or informally GNU.
There you go, I'm informal. So the GNU,
Doing names for computer.
so GCC stands for GNU, which is an organization, they named themselves after this animal.
I think saying it a little. Do you think?
New.
No, there's no.
I
G. I think I hear a little.
There is no G.
Maybe.
GNU is an organization, they made a C compiler, so GCCs, GNU C compiler. And then you're compiling the program. What program are you compiling? First.c. Now, what is this minus O? The minus O says I'm creating a compiled version of this program, right? Well, what name should I give that compiled version? Well, the name I'm going to give it is first. Not without the .c, because it's not a C program anymore, it's a compiled program. So that's what we explain here. Okay. So that's how we compile. We type that and hit enter. A little note, in the previous lesson, we learned that we programmed in C in Windows, did we?
No, I don't think so.
We didn't program in
But it's
C.
the same thing, the same idea.
On Linux, different routines are sometimes implemented in different C code. For example, the IO routine printf and scanf, etc., are implemented using Linux system calls, which are write, read, etc. On other systems, these system calls are sometimes supported, sometimes not. And accordingly, the programs that use the sometimes work and sometimes don't. If we want to move a plan from one infrastructure to another, I mean, give me the program. If we want to move a program from one infrastructure to another, we will have to look into it. In other words, you don't necessarily take a compiled version of a program and try running it on, or even a non-compiled version. Well, I mean, printf should work anywhere, but
Yeah. That's why executables don't work on Mac.
executables from one computer won't work on another computer, except PCs, they'll all work together. Okay, so I don't know, we ran that program, this was kind of this slide didn't really lead us anywhere, but we compiled it, and presumably if we ran it, we would see 5 and then 6. Okay,
It's
and
just
then,
explaining the Linux philosophy of just using the terminal to compile stuff and do it that way instead of the way we've been doing it in Windows, which always.
what's the
like
philosophy behind it?
No, I'm saying that's more of the Linux philosophy. In Windows, you always use a interface.
Right. Yeah,
It's just, I think, explaining that is the way you do it on Linux, like like
in
most-
general, yeah, I mean, there are environments,
You could, but I'm saying that's like.
that's the way it's generally done.
Yeah,
Because if you want a windowy kind of environment, you'll use Windows. If you want a GUI, but people do use GUIs in Linux. You can compile it with a GUI that'll be very nice. GUI is a graphical user interface, as like a window. So here, creating process. Until now, we have seen the creation of process by running a certain process through the terminal. Right? We ran a process through the terminal. In other words, we typed, for example, the word top, and we ran a process. Or we could type the word first, and we run our first.c program. Just type the word first. That's how you run it. On Linux, a process can create another process. Why should a process create more processes? Well, to divide the task that the process is working on into several processes, into several processors. Did I say that to you guys before? I think I said that. That if you have a multi-core program and you're only running one program on your computer, then all the other cores will sit idle.
It doesn't run it like.
It doesn't, yeah, exactly, you won't gain any benefit. If you want, however,
You need
your
a
program to be
multi-
divided on all 4 processes, so that you'll create 4 processes and have each one do part of the job. So that would be one, to use several processors.
Or isn't that like a multiprocessor?
No, we're talking about processing, we're called multiprocessing now. We're not talking about threading. To divide the code, it is working, so it could be several processors or several computers. Then it would be called distributed system, a distributed
course on
program.
distributed systems here.
What?
Is there a course on distributed systems?
I don't think so. To create processes that should only be created if a particular process is triggered. That's the third reason to do it. Maybe I want to process, but only if something happens. Please note, these are processes, not threads. Where threads are like sub processes. These are a full-fledged process. That is, in separate tasks, these are each separate tasks and not subtasks, even though there is a connection between the master process and the child process, but they're all independent processes. There's one original and there's the copies, but they're all processes and they're not threads. They're not what we call lightweight processes. So how do you create a thread in your program? I mean, not a thread, a process. We use a system called fork. Fork is called fork because you come to a fork in the road, and as Yogi Berra says, what do you do when you come to a fork in the road?
Take it.
You take it.
How did you guys do that?
So a fork means. Yeah, that's Yogi, you can look up Yogi Berra quotations.
I'm Canadian, is that it?
Yeah, I actually lived in the same town as Yogi Berra, Montclair, New Jersey. You know, you guys are not gonna know who he is, are
Yogi Berra? Classic Yogi Berra.
you? Not Yogi Bear,
I didn't.
Yogi
say that.
Berra.
I think so.
No, Yogi Berra.
They have donuts.
baseball player.
Yankees cat.
They have bear.
Okay.
We're just so
What do
deep
you
into
think of,
American culture right now, I'm
the Mets
so
this year?
lost.
Mets?
Yeah. The Yankees also
What do you
lost.
think of the Dodgers?
They won.
1923 maybe?
They're pretty good.
Oh,
They look pretty good.
Why does this guy, Ohani or
Otani,
Otani stand so straight
why is stand so straight?
when he bats? Is that the way
Otani.
they do it in Japan?
What?
Is that the way they do it in Japan?
Is that the, I would not be able to tell you.
He's left-handed. Oh, he does stand straight. He's just standing up. He's just like this.
Yeah.
See?
But then
That's
he
sweet.
does bend a little bit when he starts.
He's just standing up. That's kind of crazy.
Yeah,
He's just like,
got a very big strike zone.
yeah,
Okay,
apparently it doesn't matter.
so. System called fork. We will now get to know the creation of process using a system called fork. So we're gonna have a process create another process. When we typed, let's say first, our name of our program, enter, we created a process. But that was just creating on the command line. Now we want to create that the program itself creates other programs or creates other processes. So the call does not accept parameters. You just type the word fork like it's here in your program. Now it returns a value. You see that it returns a value here? It can actually return the value -1. If it returns the value -1, that means it failed. That means it didn't succeed in doing what it's trying to do. But it could succeed, in which case you'll create a new process. What process? I didn't specify what the other process should do. I just wrote the word fork. What other process, what am I doing? The answer is, I'm doing the same process as I had already started. But I don't start from the beginning again. I pick up at that point. So in other words, at the moment I type the word fork, I now simultaneously have two processes running at that moment, and they're both returning a value to this variable PID, and they're in fact two separate variables called PID, each one in each process. And never the twain shall meet. They're two separate processes. They each have all the variables that were defined, their own copies of them. Now, if I already assigned I the value 5, then I in both programs will be 5. But if I change the I in one of the programs to 6, the other one will still have 5.
How do you manipulate?
Now, how do I wait a second? How do I manipulate? We'll see in a second. I don't know if I showed, but wait a second. So now when I come to this line, this I++, two processes are doing it. Because at this point, both processes have reached this line. And they're going to both make I to 6. And then when they print out, I'm going to get, what am I going to get on the screen?
6.
6, 6. Let's see if that's what I wrote here. Oh, this is how I'm compiling it. GCC -O program 1. It's generally accustomed to, if the name of the program is program1.c, then the output file, the O stands for out, or object or output file, is prog1. So I run prog1, and what do I get? prog1. Oh, before I explain that yet. So, wait, let me just finish what's over here. The important thing is like this. The parent process, see, remember I said that the fork returns a value. It returns -1 if it fails, but if it doesn't fail, I didn't say what it does return. So PID gets the value. What does it return? So the answer is like this. If I'm the child process, then I get the value 0. The parent process receives, no, the child process. The child process here gets the value 0. The parent process gets the ID of the child that he created. The ID number, the PID number. So if you look over here, if I had process 1000, he was the parent. It says process 1000. And he comes along and he runs the fork. PID will be 1200. Why 1200? Because that's the value that fork returned him. So in the parent process, he has the value PID equals 1200. Now, does that 1200 have any meaning? Yes, it does have a meaning. The meaning it has, it happens to be the PID number of this new process that I created over here. Now, but he won't get that value. He will get the value 0 in
Should it be
PID.
-1?
No, it won't be it'll only -1 if it didn't succeed in creating a child.
Oh,
In this case, I created
oh,
a child.
it starts from after that, so it's not.
If PID equals -1, then it means there's only one process, there's no two processes.
So we just by default put a 0 there
Where?
on the.
Oh,
second
you always
process.
put a 0 here. Not by default. The rule is like this. When I do fork, the parent process gets the PID of the child, and the child process gets the value 0. This is very useful. Because what could I do now? I could write, like, for example, if. Can anyone complete my sentence? If
PID.
Equals
If
negative.
PID equals,
-1.
well, that would be you're checking for an error, that'd be a good thing to do, but what else? would I do?
Greater
than 0.
The
If
PID.
PID equals 0, then I++, else, no, nothing. So then only one program will change the value. So by using this if and the fact that I know that the return value is 0 when it's a child, I can divide my work. I can say the child will do something. How do I know it's a child process? Because PID is 0, and it's always 0. I can't really know what the idea of what value the father is going to get. It's whatever value is available to give for the PID number of the child.
This is such a weird feature. I don't even know when you would ever use this.
Less.
Well, before there were threads, it certainly was useful.
Yeah, that's what I'm thinking. It's like, it feels like it's similar to a thread.
If less.
Right. Okay, so here, what about this example? We love to do these kinds of examples. How many processes will there be here?
Final question.
One?
It's 2 to the 3,
I don't know.
Right, it's 2 to the 3.
What, why?
because each time you're duplicating.
Well, at this moment, I have 2 processes.
Why?
That's what
Oh,
fork
before,
does.
yeah.
That's what
And
fork
then
does.
We're not assigning it. Oh, no.
It doesn't matter.
Doesn't matter, I still ran it. I still did it. I mean, assuming that none of them returned -1. So, yeah, that's the problem with the exams in these courses. You write something like this, and then you go, oh, well, there's only one process.
But why
They
is
all
it
fit.
not, why is it not?
We have to write in the exam. Actually, in my exam in
Question.
Unix, I write in the very top of the information for the student, assume all functions succeed.
Wait, why is it not 6 though? Why is it 8?
It's 8.
It's a tree.
Because look, this is 2. At this point, we have 2, right? Those 2 come along here, and each one of them goes to do this. So now how many do I have? 2 and 2, so 4. Now all 4 of these come to this line, and they make 8.
Got it. What are the 2 that, what are the 2 from the first column?
So there was one program. Okay? You start with this. When
No, the
you
original fork, yeah. Why
This
is that 2
fork
and not 1?
just copies the whole program and starts a new one, but from this line.
So 2,
on.
okay, 1.
So now you have 2 in
Got it, 2 to the 3rd, perfect, thank you. Sorry.
It's a weird feature. It's not, I don't see the point, but.
Well, now that the thread is not much, well, there are some points, it will see, there are some reasons for it, okay. Here's another program, how many processes are being created here?
This is also 2 to the 3rd.
It's the 4th.
Or 2 to the 4th. Yeah, 2 to the
With
4th.
the 4th,
Front is here.
okay. Get PID routine. So more, I should have put that in green. But. Some more functions, there's one function called get PID, you can see in green. And what it is I just run that function. In my program, and it returns to me my PID value, that's why it's called get PID. Makes sense. Also, any process can find out who its parent process is by using get PPID. Parent process ID, get parent process ID. And then there's also a wait function. The wait function is when the parent says, I'm going to wait until a child of mine finishes. This is for like synchronization. Let's say I made a child to do something and then I went on to do something. Now I don't want to finish, I don't want to continue until my child tells me he's finished. So we have a special function called wait, which waits for a child. Now, which child does it wait for if I have multiple children? The answer is it waits for the first child to finish. So it's non-specific. But there is a function called wait PID where I can specify which particular ID I want to wait for. And of course, do I know the PID of my children? How do I know? How do I know?
It is on your PID, you can
What?
save it.
From just fork, you know?
From whenever I did the fork to create the child, I got back the PID. So if I store it, I still have it. Okay, here's another program. What will be output on the screen? Well, I equals 5. Then I say, oh, here's exactly what I was telling you about the if. This is exactly the if thing. If PID equals 4, if PID equals 0,
The indentation is not
there's no indentation.
correct.
There's no indentation,
There
so
should be, though.
it doesn't matter. You don't need indentation, see? Not required.
No, but if you don't put the curly brackets, you do, I think.
No.
You do not need to
Just
know.
the next statement.
Okay. So.
So
yes,
if
that the-
it's 0, which means I'm the child, then plus. So what will I get here? Well, both, if it's not the child, then the father will just jump straight to here. So he'll print 5, but the son will print 6. So I'll get, will I get 5, 6, or 6, 5?
Well, the child won't print anything, right?
No, they both will.
What is percent sign?
Remember, when you don't have
Sorry.
curly braces around an if, then just one line is part of the if. You should know that. You learned C++, right?
Yeah, that's what I was saying. It's just, I thought you needed the indentation,
No,
but.
the only language I know of that needs indentation is
Python.
Python.
But the thing is, maybe it's just for clarity's sake, that's the way you do it anyway.
Sorry, we're talking about for clarity's sake, what's
No, no,
required?
it's not completely good.
Yeah. So wait, so what? So will it be 5, 6 or 6, 5?
I would
We don't
say
know.
5, 6 first.
Well, the answer is
Why
It
is
takes
it
less
goes
time,
there.
one less instruction.
Printing on it.
if you're in an exam and you have an option to give, it could be either, then that would be the correct option. But if you had to choose, if you had to choose which one is more likely to be, what would you say?
5,
Yes.
6.
It would more likely to be, no, I just want to point out, first of all, this is called a race condition. We talk about it in this course. A race condition is a major topic actually in chapters 6 and 7.
Correct.
But a race condition means that it depends who gets to the end of the race first. I don't know who's gonna get to this print line first. Because both of them are running to get there. And it could be the child gets there first or the parent. I have no way of knowing. There's no wait. If I would have put a wait in there for the father, if I would have said else wait, you know, then the father wouldn't print until the child finished, which is the after he printed. So then I would know the order. That's why the wait is very useful. Then I would not be a race condition. But as it is now without the wait, both are running, and whoever gets to print F first prints first, and whoever gets there second prints second. So I can't know. Somebody's gonna print 5, somebody's gonna print 6. But which one is more likely to occur?
5, 6.
5, 6.
5 is
One less
if it's the
instruction.
child.
Then
Ah,
it's default.
yeah, there's 2 reasons. So it's more likely that the father will print first for 2 reasons.
6 wouldn't print at all.
The-
Why would it print the child?
Why would 6 print? Because the child is 0, and so he'll do I plus plus and
Why
it'll
would
become
it print
6,
numbers?
and he'll.
So confusing.
No, 5 is from the first.
There's a fork here. I got 2 programs
I
running.
know, we only put one print statement. How are we printing 2?
Because there's a fork
Program
here.
has its own print.
What?
It literally copies the program. It copies exactly the same thing from that point on.
From, oh, I thought you meant from that point and above.
No.
No, everything that happened above,
Oh.
I have all the data that from.
Sorry, okay, I thought it was from that point in.
It's like having a pointer inside a program.
So therefore there's 2 programs and that's why we're checking. Okay, got it.
Yeah, and that's why it's a race condition. We don't know who is going to get there first. How do you guys know about race conditions?
Uh,
You're supposed to learn it in this course.
Yeah.
Data security we're talking about.
Yeah, you know.
Ah. Okay, so wait a second. So what's my point? So it's gonna probably do that the parent prints first for 2 reasons. One, you said because he got an extra line, I plus plus. But that's, you can execute that in like the billionth of a second.
Yeah.
But there's something that's much more slow that the child has to do.
So creating, copying everything.
Which is creating the child.
Yeah.
The operating system, for the parent, he just says, okay, parent, continue on your merry way. But for the child, he's got to build the child, and that takes time. So generally, you'd say the parent gets there first. So let's see, what does he say? What did I write here? 56 or 65? And it just,
Oh, jeez.
the
Or
answer is,
it's
no,
both.
the correct answer is
Either
that. Either or, you can't know. Ultimately, you can't know, and that's the best answer. But it's also a practical answer that's likely to be, I'm saying the practical answer is also a useful question on an exam. Because it shows you that you understand this concept, that it takes time to create a process, and therefore that is a likely question. And I mean, a reasonable question.
Just find those 2 days.
I did a question like that on the exam, and the students complained, how you can't know? And I said to them, but it's a multiple choice question, there was no option called you don't know. So you gotta pick what's the most likely. If there's
Please
an
make
op,
it clear.
what?
Please make it clear, though. You're picking the most likely option.
What else would you pick? The least likely?
Where's that?
Right.
You're right, I mean, it's not so fair, but it is kind of fair. In the end, I gave him a 5-point
Yeah.
bonus because
Which one?
of that unfairness, but I still think it was fair. What are the PID values in rows A, B, C, and D? Suppose the values of the actual PID of the parent and the child are 2600 and 2603. So what are the values in rows A, B, and C? We gotta analyze this. But first of all, look at the structure of the program, it's very nice. We check if the PID is less than 0, that means it's an error. Are you guys with me, or you're following along? Or you're doing Minecraft?
I'm doing Minecraft, they're following.
If PID equals 0, then what? If PID equals 0, so I'm a child. So I say like this, get PID 1, wait, what is PID 1? I look at the top here, I have a couple variables. Notice it says PID underscore T. That's a type. It's a type, it's basically an integer type. Don't be confused by that, it's just an integer. So I have PID 1. So I say PID 1, get PID. Well, that's gonna be my PID. Well, I'm a child. My PID, the value PID will be 0, but the value PID 1 will be my actual PID, and we said my actual PID is 2603. So therefore, he's gonna print what?
0 to 6.
He's gonna print 0, 2603. So here at line A, it's 0, and here. By the way, you see in this question, he didn't say what will the printout be, because he didn't want to deal with race conditions. Of course, he could have dealt with race conditions by doing what I said, which is weight null here. This weight null, instead of doing it here, he could have done it before. You understand? If you put this line right after the else, then we would have no race condition. We would know that the child will do his first. Because the parent is waiting before doing anything.
No, but
So the child, in this case, we don't know what the order of printing is going to be, and it could be intertwined. It could be this line, then this line, then this line, then this line. We don't know the order. But here, that's why you said, what's on line A and what's on line B? So we said again, 0 and 2603. And here it's going to be,
2600.
it's going to be PID is what we already got, which is 2603. It's going to be 2603.
This is for the parents.
Because the parent got, when he did the fork, he got the PID of his child. Oh, sorry, and that's 2603, yeah. So this will be 2603, but PID 1 will be his own, which is 2600. So that should be the answer, let's
is
see.
weight null considered weighting, or it's just not?
Yeah,
How do I know if it's a child process?
It is a weight.
I didn't give you the whole description of the weight function, but the weight function can also take an integer, a pointer to an integer here. But if I don't care, pointer to, in C, I want to tell you this actually an important point. How do you return more than one parameter in a function? Functions only return one value.
You pass.
How do you?
You pass an address to the.
So one way, there's two ways, but one way is that you pass a pointer to a variable, and that variable is empty. You don't care what's in that variable. And then the function itself will have a pointer to it. It can change it now. And when the function finishes, you can now look at that variable, you have a pointer to it, and it'll have a value in it. So weight works like that. Weight can take a pointer to an integer, and then you can get a number here, which is the return status of the child when he finished. If there was like a return 7, you might get 7 over here. I think something like that. So, or it's the status, I think it's whether
Well, how
it's
is it
success, it may be the success or failure status of it, actually. Anyway, it doesn't matter. The weight can return a value. But in this case, I'm not interested in the value, so I just write null. But I have to write something there because the weight function is defined to take a parameter. So I gotta write some parameter there, so I create it null. That's to tell that I'm not interested in the value. So actually, this weight
It's useless.
is completely useless.
I mean, it makes
I don't
it so
know.
one of them is returning before that. Actually, that doesn't even do that. Yeah,
Yeah, it means that the father will definitely finish last. But he'll have printed already.
yeah,
He'll have done all of his job. Yeah, it's a stupid place to put the weight. The weight should have been before.
Yeah.
All right, so 0 by 0. Oh yeah, 0,
Yeah.
2, 3, so 3.
Why 0?
That's right. No, we're all right. Everything's right. Everyone sees the answers?
Yeah.
That's what I said.
Why 0?
Because the child, we check, first of all, it says PID equals 0, so if I print PID, it's got to be 0. Otherwise, it wouldn't get into the
And
set.
the father's and the parents still 2603. Okay. Got
The
it.
parent is the number of the child, and here is his own number.
Wait, what is what?
It's a pity that this example didn't do get PPID. That would have been interesting. If the child would have printed and get PPID.
How do I
the parent do?
I'm sorry.
If the parent does get PPID, then he gets the operating system. Or he gets the shell. If you ran it in the shell, when you log into the computer, you get a shell. That shell itself is a process. And when you run a program, any program you run is a child by definition of the shell.
What is the shell speak?
So if the shell does PPID, he'll get probably the operating system, which is 1.
In order to do the operating system.
I don't know. Oh, what is the operating system? You might get 0. It's the boot, which is the bootloader. Bootloader is dead.
In this.
Actually, wait a second. The bootloader is dead.
What if it got
That
upset?
means, yeah, he's an orphan. The operating system is an orphan. His father's dead. Yeah, no, in general, the booter is 0, as far as I recall, something like that. The booter is 0 and then the operating itself is 1. I thought the kernel is 0 and the operating. Anyway, yes, go ahead.
So the PID 0.
There's something called init. There's something called init. And init is 0 and the operating system is 1. Yeah, go ahead.
So is the PID 0 or 2603
For who? The child is 2603. It said assuming that the PID of the child is 2603.
It says PID is 0.
Oh, because PID is called, that's the name of the variable. But that doesn't mean that the value in it is actually a PID. It's just the name of a variable, PID. I can put it into that any value I want. Put it negative 325.
PID.
What?
325.
PID 1 is the PID.
What?
The code you program is PID 1.
In this code here, I write fork, PID equals fork. Fork returns 0 to the child process and the PID of the child to the parent process. So the parent process got 2603, but the child process got 0. So when the child process comes here to print PID, he's going to print 0.
Yeah.
That's the special behavior of this fork, that it returns 2 different values.
PID 1 is equal to get PIDs, but not give. Why does it not give 0?
PID 1 over here is get PID, which is the child's process. Just because the fork returns 0, that doesn't mean that the actual PID of the child is 0. The PID of the child is 2603. It just he just returns that value. He just likes to. That's his thing that he does. It's just his thing. You know, Louis C.K. has his thing, and he has his thing.
Is if the child makes another child, is that grandchild a 0 for his multiple?
Yes, every PID that is set equal to a fork will get a 0 and a number. It'll get one
Yeah, so
process.
how do you differentiate between the child and grandchild?
Programming. It's all a matter, simple matter of programming. Yes.
Specifically, what line that is like the work run after? Like if you put 2 commands on the line PED equals 4, you do PED.
Yeah, he doesn't have an example like that. We'll do that in the Unix class. But yes, you write fork equals fork.
No, and it's, PID equals whatever, some function and fork. So like runs both.
Oh, that's.
Is it going to run
With
that?
an and symbol?
Yeah, the and symbol, because like that's how it works, right?
Single and,
We'll find it.
The double,
a double and, oh, double and will have to run both.
yeah, so will it run that first function on both or only on the parents?
It'll run the first one it encounters, which is the left. And then it will come to the right and both of them will run the right. You're asked, I didn't bring a marker. Anyone have, oh, maybe there's a marker here. No, anyone have a marker?
No.
Okay, well, I can't really draw it, but if I wrote fork and fork.
Yeah.
So the first fork will create two processes. Now the second fork will be run by both those two processes. Well, okay, what will be the output of this program? So fork equals PID equals fork. If PID equals 0, so I'm the child process. Now value, which was 5, should be 20. Return. Okay, so he didn't print anything, he just changed the value. Now this parent actually does wait for the child to finish. And he says, print out value. What will the value be? 5. Anyone say different?
Because it waited for the process to finish?
It doesn't matter.
It actually doesn't matter.
Only the parents print.
What is the PID?
No, that's just to make sure that this is to make sure that the parent won't try to print before the child did what he did.
But
So the
what-
child definitely did what he did.
Yeah.
The question is, does it have an effect on the value of value?
Absolutely.
Return on.
I'm not sure because now it's a global variable, so. Is
Oh,
that good?
No, it's a different process.
Yeah,
different process.
It's global variable or not.
The answer is the answer is print 5. Because the variable, even though it's global, that just means it's global to functions. But these are two different programs. So there's no connection. So the fact that the child changed the value has no effect on the parent, even if the parent waits for the child to finish.
And the wait always gonna wait until it finishes? Like 100%? Or it's going
What?
for a specific amount of time?
Waits forever until the child finishes. It's actually a very important term that you have to know for the exam, which is called a blocking function. A function that blocks as opposed to a non-blocking function. Function that block means it does not finish, we call a function and it waits forever until it does what it's supposed to do. If it's, in this case, it's waiting, it could be another function. You could have a function that say reads from a file. Well, reading from a file is actually a funny function. I mean, all functions are potentially non-blocking because they could fail. Right? If I try to read from a file, it doesn't exist. That wasn't opened. There's no file in that.
Waits for it to return.
No, it would be a non-blocking function. In that case, read would not block. What's there to block for? There's nothing to wait for. There's no, he didn't succeed. It's an error. Whenever you encounter an error, you end.
Yeah, but the execution flow of the program is still waiting for that function.
No, it's not.
It
The
happens
function ended and the program continued.
Yeah. The function.
If I
ended.
call a function
You're not
And
waiting
it-
for.
and the
Yeah.
function
The
fails,
function ended.
exactly, that's not, so then it didn't block in that case.
It
Walking means that.
didn't block
Walking
in
needs
any
to clean so it
noticeable
doesn't happen.
manner. But, the function still had to, the outer function, the program still had to wait for the function to. finish.
I think all programs wait for functions to finish.
I think
Exactly.
walking-
That's not what we
maybe
mean
that-
when we say blocking. When we mean to say blocking is, we say that this function is going to do this thing, come hell or high water. In other words, I am going to do a thing called open this file. And if it takes me a year to open the file, I'll wait a year. If it takes me forever, if I never succeed, I'll just sit there. Now, there's a non-blocking function theoretically will never return an error. You think about it, because I'm saying, do this thing. I mean, in a certain way, you can think about it, do this thing, and wait until you succeed. So it's like saying, if I send somebody to the shuk and say, bring me back flour. He runs to the shuk, he doesn't find flour, shuk says, there's no flour. I said, well, it was a blocking function. I wanted you to go to the shuk, and there's no flour in the shuk, just sit there until eventually flour comes, then come back. That would be the difference between,
Blocking is kind of like waiting.
yeah, in a sense, it's waiting, it's a kind of waiting, but
But
wait,
wait isn't the walking function.
no, it is, well, it depends on the circumstance. For
Because
example, if I wait for a child and there is no child, then it immediately returns.
Yeah.
But if I wait for a child and the child is in an infinite loop,
You'll never,
then I'll never return.
like the flower.
Try debugging that. You're waiting for a child, and
Waiting
you
for it.
realize eventually that the child is
a
an infinite loop.
non-blocking function, I think of something that starts something asynchronously and then the program flow just continues.
2 days.
But
to find out, or is that?
Yeah.
The classic example of non-blocking
And then
function
another 2
is
days.
with semaphores, which we're gonna talk about later.
What?
Where with semaphores or mutexes, you know anything, you know about mutexes? We'll learn that. We'll talk about it. We'll talk about it again.
Type of semaphore we're talking about?
Semaphores, we'll talk about it.
1960s, 70s? It's different.
Okay, let's continue. Running processes in the background. Oh, this is what I said about FG. Remember I said we're gonna talk about FG and BG and jobs. I love the BG. Running process in the background. Background process is a hidden process that runs without graphical representation, including services that are not system process. So, in other words, a process, if I turn on my computer and I do PS and I list all the processes, I might see hundreds of processes. But yet I didn't notice that they were running, so they're hidden. He adds here that right, it doesn't have to be a system process. Anything, when we run programs from the terminal, they run in the foreground, which means that the terminal is now busy waiting for this process to finish, and anything that I print, that the process prints, it'll print in the terminal. So the terminal is kind of useless now. They run in the foreground, they take up the foreground and complete their work in some short time, hopefully. It may be that while the processes are running, it is necessary to perform a more urgent task in the terminal without affecting the processes that are still running. In this case, the blocking process can be sent to the background. In other words, this is a misuse of the word blocking, but the idea is the process that's causing me trouble, that's using my terminal, I want to put them in the background, where it will continue, and now the terminal can be free and I can use it for other work. How do we do this? So I already explained to you one way. I said that you do Control Z, which freezes, which sleeps the process, and then you can do BG, put it in the background. But you can also start it in the background, like this. Run program called example, ampersand. And type this ampersand, and that means run the program, but don't run it in the foreground, run it in the background, so that the terminal is still available for me to use. Okay. Main fork, if fork does not equal 0, while 1.
What?
Yeah, that makes sense.
What is while one?
What's wrong with this process? While 1, you heard this up? While 1 is while true,
Yeah,
and while true is an infinite loop.
yeah.
This is your thing.
So this is an infinite loop. And then, well, what did I do here? If fork is not equal to 0, which means it's the father. If it's the child, wait, this is a weird program. If it's the son, then fork will equal 0 and it won't do the loop and it will exit. But if it's the father,
If
So what's the point of the fork?
they don't just get stuck in.
if it's the father, then it will
They'll
just
get
be in a
stuck in
loop
the
forever, do nothing. What's the point of the fork? I have no idea. I didn't write the program. It's a kind of stupid program. You could have just written while 1. In fact, an endless process is created. I don't know what it's talking about. It's not an endless process. The father is endless. The child will be 0 and will end.
Yeah.
So we didn't create an endless process.
They brought it.
No, so the
No, it's not a typo. It is an endless process. The father is an endless process.
What happens here when you do the fork? Because how does the program get copied? Does this line get copied as well? Where the fork is?
Yes.
Or not?
Yes.
Yeah, no, it is.
GCC, okay, I
But then if
compile
it gets
this,
copied, then it's forking.
compile this example, run the example in the background. You see, you're just trying to show background. Why is he trying to show running in the background? He's trying to show that I still have the terminal. And even though this process is running, I can do PS minus A1, I think that is, or AL, I don't know. AL, I'm not familiar with that flag actually. But PS minus AL, and I see example 3 is running. Now, I also see that somebody is a zombie, Z, whatever, there's some process that's a zombie, sleeping, the terminal is not doing anything really, but this process that I'm running is running. R stands for running. So the process is running forever, and the terminal, the TC shell, is the terminal in this case, the shell. I don't know why he's got TC shell, not bash, but he's got TC shell running. And he's run, and the shell is sleeping because the shell is really inactive. He's just waiting for the process to finish. And this, I think, is the Z, which is a zombie, I think it's a zombie, is the child that I created. Why is it? Yeah, the child is created, and the father. Oh, what's a zombie? There's a concept called a zombie process. I think I'm gonna talk about it again, but I'll tell you now also. A zombie process is just like a zombie. Is the dead but not dead. So why is the child dead but not dead? Because the child is 0, right? And he died.
Yeah.
But it couldn't really die because maybe the father, after this while finishes, because remember, the operating system doesn't know how long this loop is going to be. Maybe there's another line afterward. So whenever this loop finishes, maybe the father is going to do a wait. But the wait is supposed to give him information about the child. Remember we said that the null there, but I don't have to write a null, I can have a status. That information has to be stored by the operating system about that child that's dead. So the child is dead, but he's not completely out of the system. He's sort of information about him is still stored, and we call that a zombie process.
Why does the wait need information?
Well, let's say I ran a process and I want to see what his status was. Did he succeed or fail? So I have a status value. So now if I want to kill the process, I can do this command, kill minus kill, and then %1, which means the first job in the stack, in the list of jobs, in this case it's only one, but in the list of jobs, the first one that the last one that went in, kill it. It's a stack, so it's the last one that went in. The way to stop the process is to simply kill it. Of course, this requires that the terminal be available. And of course, it is available because I ran in the background. Here's another example. Where both the father and the child, maybe that's why he did this
You
example.
don't need an if. Here, this one you don't need an if, you just do fork and then while one.
True.
Yeah, it's like.
Okay. Example. And now when I do PS, I see that they're both running. There's no Z. Notice that there's no zombie. And now I have to do kill 1. And then what did I do? I kill both of them. By the way, kill -1 is a bad example. You should have done kill %2. It would have been more interesting. But anyway, okay. Oh, he's good. He's good.
On this guy.
Wait, I want to take a break for a minute.
We're on the last slide.
Was this the last slide? Okay, so
Yeah, that's.
We can still take a break if you'd like.
no.
I'm just saying.
Thanks for the
Knowledge
information.
finished.
System called execl. Now execl actually works together with fork, because what execl does, it doesn't create a new. Here's the key point. It doesn't create a new process, but what it does is it converts my process into another process. What do I mean by that? I mean, if I had a process that was doing nothing, but now I say I want you to run another program, so then my process will start running that program. I won't create a new process, just that my process will be now that other process, that other program. So for example, here, what happens in this program? I say like this, if fork equals 0. So who am I? Child or father? Child. Then I'm the child, so execute, execl means execute list. Execute the program called cal. The location of cal is in the directory bin. And I have to write it this format. I have to write the name of the program twice. I write first /bin/cal, which is the path of the program, where it is. And then cal, and then 5 is a parameter I want to give it. 2023 is another parameter I want to give it. And then null to indicate the end of the list of parameters that I'm giving the program. So essentially, it's as though I wrote on the command line cal 5 2023. But it's in a program. Instead of on the command line, I'm writing this. I'm now in a program and I'm writing cal 5 2023. But I have to call a function call, and that's execl. And now the child process will now run this command. When he finishes running this command, he will execute. He will die. He will not come back and run the next line here. So if if this comment here were not a comment where we're, let's say, print hello world, it wouldn't print it.
Why? Yeah.
Because what I'm doing is I'm saying, run this other program. And that's it, don't come back. I converted my process now is that other program.
Oh,
So there's no going back. I am that program.
That's
I have
right.
nowhere to go back to. It's not a function call.
that's why it doesn't return anything.
Execl actually could return -1 if it fails,
I see.
but it doesn't really return, it's not gonna return 0. If it would return like some value, then I would never get it. Because once I said execute this, then that's what he is doing. Like I'm sending him to the moon. This process, this child process is saying, I am now converting myself into this program cow. The program cow doesn't know where to return to, so it can't return.
So why would you even need to know that if it fails? Because if it fails, it'll go to the next one anyways.
Right, so you don't really need the
No,
-1.
because you could have.
Exactly, you could just write
Print.
after that line failed, exit. Now, after this line, if it comes to the next, then you could say, I failed. But now look, the interesting thing that they actually didn't do here is,
Fail. But you know that.
now look, what does the father do? The father does
Don't-
sleep 1. What does sleep do? It waits for 1. How much time does sleep wait for? 1 second.
You're.
So presumably Cal will finish whatever it had to do. What would be a better way of doing this to make sure this is actually technically not a good way to program, because maybe this program took 2 seconds. I don't really know how long this program takes. But what if I wanted to guarantee that the father waited for this to finish? What command would I use?
Wait.
Wait. If I did wait here, then the father would wait for the child to finish. Because even though I ran a new even though I converted my child into this cow, he's still the child. His PID didn't change. So and he still has a father who's me. So when this guy changed, I can still do wait on him. Now, what did I write here, or what did I translate here?
This child.
I have no idea, it doesn't really matter, it's some program.
Print the calendar, so Cal 5/20/23,
Oh,
prints the calendar for May 2023.
I didn't realize.
Okay.
Wait, I have Linux right here, I can just play around with all the things on it.
I have it too, but I think that's.
Yeah, WSL, you can do it.
Yeah, but yes, I mean, you just go on the command.
Let me see if Cal exists, like at all. Yes, that's basically what we're doing. We're putting Linux commands basically inside the C program that's gonna get executed.
That's like cow. I think so.
You
I
know,
think that's such a gym. I can do this.
Are we done now, because we just finished the slideshow?
Alright, so we're done now.
Oh,
So now you can work,
there's an end call.
what time did we finish today?
45.
So
There's market in 2 minutes.
So we can just stop here. There is a stop share. Stop recording.
Can you help us with the?
Are you sure you want?